Most op-amps are powered by what is called a bipolar power supply. This basically means that you have two voltages, a positive voltage and a negative voltage, and usually these are the same magnitude. One very common possibility is plus and minus 15 volts, but it's not uncommon to see plus and minus 12 or plus and minus 10 or plus and minus 9. And with the increasing use of lower and lower voltages in circuits, you may even see supplies that go down below 5 volts. Standard op amps have a little bit of difficulty operating much below about 5 volts, and we will see why that is the case when we talk about the non-ideal characteristics of operational amplifiers. But for the moment, we will just assume we have a standard bipolar supply, and for the most part, I will assume that is plus and minus 15, but there's nothing magic about those numbers. As mentioned in the video on the basic inverting amplifier, if you have current entering or leaving the output terminal of the op-amp, since it cannot return to ground through the input terminal, since the current there are assumed to be 0, it gets back to ground through the power supply connections. So that's how Kirchoff's current law is satisfied. Now, let's look at what is possibly the absolute very simplest operational amplifier circuit, since it has no other components, only a single added wire. And that is what is called a voltage follower. The voltage follower simply has a wire connected between the output and the inverting input. There's your negative feedback, certainly negative feedback with a wire there. And the single input is connected to the non-inverting input. Now, let's remember our assumptions. First of all, if we have negative feedback, we absolutely have negative feedback here. If we have negative feedback, the op-amp will do what it must in order to make the voltage at the inverting input equal to the voltage at the non-inverting input. Therefore, since we're connecting Vn to the non-inverting input, the voltage at the inverting input is also Vn. But since you've just got a wire connected to the output, that means Vout is Vn. You say, well, this is pretty stupid. Why in the world do I just need to make a copy of the voltage? What good does that do? Well, what good that does is this allows you to buffer a voltage. For example, if the circuit generating Vn had a Thevenin equivalent of 10K, and you need to drive a circuit whose input impedance is 1K, then all of a sudden you are going to load down that driving circuit, and you're going to lose about 90% of the voltage inside of the driving circuit. You're not going to have much left to drive the actual circuit, the one with the 1K input impedance. What this does is this says, okay, the source doesn't have to produce any current. I'm not going to get any voltage loss in the internal resistance of my driving circuit because that op-amp does not have any current going into that input, but I've got an exact copy of Vn at the output, and then the op-amp itself will produce whatever current is necessary in order to drive the load and maintain Vn. So this gives you a way to buffer one circuit from the effects of another. This is really quite important. It's very simple, but it's really quite useful. We'll see some more specific applications of this circuit later. By the way, this circuit is called a voltage follower because the output follows the input. So the voltage follower, a really useful circuit. So far we've seen two simple circuits. This one, the voltage follower, a really simple circuit but really quite useful. And we have seen an inverting amplifier. Now, you may say, well, sometimes I don't want the sense of my input to be inverted, so it would be really helpful to have a non-inverting amplifier. Well, okay, you could put two inverting amplifiers in series, the first one with whatever gain you want, and then the second one with a gain of 1, which simply flips the minus sign. But that seems a little bit excessive. We can design a non-inverting amplifier with a single op-amp. It does have some limitations that the inverting amplifier does not, but we will see that in the following video.